Good morning. Welcome to the first Europe's Rail Innovation Days. Today here in Brussels is a virtual event, but as you can see, we are in the premises and the HQ of the joint undertaking. And I'm here this morning with Giorgio Tavarini, that is the head of the Europe's Rail program. And we are really glad to have these Innovation Days, especially because yesterday night, we had the first grants of Europe's Rail that has been signed with 88 participants. And it's not only is important because the first grant, but it's also the grant in relation to flagship project number 1, that is to establish a European traffic management for the European network, in a manner to manage the European network as one single European network. So not only is the first one, but there's a specific meaning. Today we'll be here not to speak so much about Europe's Rail. We'll be talking mostly about how Europe's Rail builds upon the results achieved in the past 7 years of the activity and research innovation of the Shift to Rail program, the predecessor of Europe's Rail. As you know, Europe's Rail is a newborn, is 1 year old. We started effectively our operation on the 30th of November last year. And since then, many things have been going on. So this morning with Giorgio, we'll go through also these the initial steps of Europe's Rail, and we will work through these before starting the different session. These Europe's Rail Innovation Days are the first one for Europe's Rail, but before we were branded under the Shift to Rail program, and we started just before the pandemic. Presenting the results of Shift to Rail with the idea to bring together our community and to discuss the progress achieved so far. One of the key elements of the partnership has been always the openness and inclusiveness, and we believe that this is also an opportunity for all actors to participate in the Shift to Rail activity and contribute with ideas on what we need to do. How these Europe's Rail Innovation Days will happen. As I said, they're all virtual. We hope that maybe in the future year we will have a combination of hybrid events. But today we have an opening session that is currently going on with me and Giorgio presenting the beginning of Shift to Rail and Europe's Rail. After we will have as first panel this morning, as first workshop this morning, a state of play of the former innovation program number 1, that is in relation to the new generation of vehicle. In particular, this will be focusing on 3 thematic areas: carbon shell, innovative doors, and train modularity, and the projects in relation to carbon next year. These are the 2 main projects that will be focused in the morning. After the lunch break in the afternoon, as from 1:30, we will have a second session dedicated to the CCA, and in particular on the integrated mobility management work area, energy work area, that I think is one of the most important aspects at the moment on the table, considering the current situation in energy. And finally, the Shift to Rail key performance indicator, because we not only do research innovation activity, but also we measure the results. And we will conclude this first day at 4:15 after the closing remarks that Giorgio will do with our chief stakeholder and relations and dissemination, Catherine, that will join us at the end of the day. Tomorrow, there will be the second day dedicated to IP3 and IP4, so infrastructure and travel experience. And at the same time, we will have a final session on the IP1, so the cross-cutting activity we have inside the Shift to Rail program, and that also have been the basis largely to set up what is today the system pillar. Giorgio, you talk about it later on. And finally, on Friday, we will start again around 9:25, and we will have a dedicated session to the rail freight, in particular IP5, and that is one of the key components of that has been the basis to launch the European Duck Delivery Program. That is, I think, one of the most known activities at the moment in the rail business. And we conclude the session after a final session dedicated to IP2, that is the brain of the system, and that is dedicated to the traffic management. Also, this is the basis for what I announced before. And we close the third days around 4:30 with closing remarks. I will try to join back because effectively I will be traveling in the next 2 days, but I will follow the event also while I was traveling. So now maybe before starting the presentation, Giorgio, from you, any expectation from these days?
Well, first of all, hello everyone, and yes, well, the expectation is especially coming also from your interest in the results of our activities. You will see in those 3 days outputs of the work being made by researchers from all over the world. I guess some of you are part of those researchers, but I think also it will be interesting for you to know what's going on with other type of activities, and especially also looking for synergies. And let's also not forget that all the works that have been doing and you have been doing, if you have been participating in the Shift to Red program, is taken up and will be, as Carlo mentioned, the basis also for the next program, where we will introduce you a bit now, but it's not the scope of this meeting, what will be the content. And you will see that there is a continuity, but of course there is also progress in this continuity, and where needed a disruption, because we need also, let's remember, we are an innovation program, so we need to bring a disruption into the system where it makes sense. And well, of course, the next step also will be that you are the player of the rail system, and we expect also that you take up those results and bring them into the rail system.
Perfect. Thank you, Giorgio. So maybe as we have here around, you cannot see it, but I assure you we have plenty of people from the technical point of view and supporting us. I will ask the people to bring up the first presentation. I know that looking through slides is not the most interesting and funny things, but the slide will help us to follow a bit the discussion. So on some I was skipping because how you can interact with us and during these 3 days of presentations. Well, as you can see, you don't have access to the microphone because we expect a certain number of people to join and come out. So we decided to keep it only via the chat. So if you have any questions, there is the chat box, and please write down the chat. The chat will be monitored, and at the end of each session or during the session, depending on the question, we will take some minutes to answer the question. The events will be recorded. So if you have a question about it, we have a privacy policy in the Europe's Rail Joint Undertaking in line with the GDPR. But in case you don't want that your name or image appears, well, take the necessary measure as needed. We invite you to follow the session at different time. It's quite simple to join the section. You go on the, you have links on our website and sufficiently to link. There is no protection, so we want to really have an open event as much as possible and be sure that everyone can access it. So, as I said, there will be a series of action. There will be interaction during the lunch break, and the next session will be having always a following link. This morning we will have the first link, so we will have a continuous section between now and the lunch break. There will be a second link for the afternoon session, and so on and so on. We will also test the results of what we have done with the survey. So you will be also invited to participate to a survey to help us to shape better the content for next years and next year and for the next years. And for this reason also, we would like to invite you to join our mailing list. Because you can have access to all the information about the progress of the program, but also we can reach to you with maybe questions and answers, so that you also can be involved directly in what we do and how we are planning our activities. So if you have any question, chat, and we will answer them during the session or at the end of the session when the question will be brought to our attention. So to start with, next slide we can go is to show where we started from. We started from the 7 years ago, in fact, more or less, on this type of a program that was integrating the different innovation program we have set up in Shift to Rail multi-annual action plan. As you can see, it was a program of a value of 920 million euros with 450 million euros funding. We had 28 members, almost 500 participants, and a combination of countries representing the European Union as well as outside European Union directly involved the activities of the Shift to Rail program. We can quite comfortably say that we will reach a high level of use and deployment of the resources made available. And this is really set the basis of the current Europe's Rail Innovation Program. The Master Plan and Multi-Annual Action Plan, the Multi-Annual Work Program of Europe's Rail have been designed on the results and the progress achieved by Shift to Rail. We have also tried to measure the results, and this is the last updated release 4 of the release 5 is correct what I said, of the Shift to Rail program KPI, to show that effectively two things. The first thing is that we have done a few things here, many projects in different phases. Are we tackling the correct elements? Are we really the research innovation is focusing on the area where we can achieve the ambitious target we have or not? But also the second is, are we going the correct direction? And as you can see, effectively, there are some numbers coming out from here. So if I take, for example, in the high-speed area, the life cycle cost, we target a reduction of the life cycle cost of 20% compared to an overall target of 50%. And the question here maybe is to understand, are we really tackling the correct elements that are cost driver within the high speed? And one area we didn't touch at all, for example, is the air resistance. That appears to be one of the key factors having impact on energy and maintenance costs and so on and so on. So this maybe is an area that we will have to tackle in the future, or thinking about how it will maybe evolve. You can see also, for example, if you take the metro area and you take the punctuality, you see we have put now a non-applicable, because metro system today are already a target of about 99% in punctuality most of the time. And any type of increase of 50% of punctuality will be so expensive and so irrelevant at the end that it will not contribute to anything. So when you read these targets and the KPI and the work we have done, you can see that effectively there is a bit of understanding behind. But if you want to play with it, you can go on the Europe's Rail website, and the KPI are available. And you can combine different type of solution coming from the Shift to Rail projects that can help to understand how each project contributes to achieve the achievement of a KPI. Clearly, an area where we are really happy to see the progress achieved so far is freight. And this is because, as you know, freight is an area where we can really change the current logistic distribution, ensuring that rail has a major role compared to the current 17% of market share that is present all in all in Europe on average. We have different countries with different percentages, but this is the current situation. I would go to the next slide now and start to discuss a bit about on another key program I've already mentioned is the European Drug Delivery Program. This started from the work that was done in IP5 in the context of some dedicated projects, but effectively went well beyond, because we had also solution coming from outside the Research Innovation Program, solution coming where the work's done in Switzerland, the work's done in Germany, work's done with different type of manufacturer that work in different area. And what we have done with the European Drug Delivery Program has been to bring together the full community. And why? Because we need to have an interoperable solution. What does it mean? One single solution, one single mechanical, digital electrical solution to ensure that the current simple interoperability delivered by the screwed coupler, so the hook at the end, remains unchanged. But the intelligence that will be brought inside by the DAC, the digital aspect and of the coupler, is the major game changer, touching all the type of business. Will be single wagon load, will be the combined transport, will be different type of wagons, a different type of solution. So I think this is a very good example of how also the Shift to Rail program has evolved from the beginning to the Europe's Rail program. And the Shift to Rail program was designed a technological program focusing on the technology that have to be serving and become ready for the different solution. With the DAC and the Europe's Rail program, we have brought around the concept of which type of services the clients will need to improve the performance of the rail system. We will go through the DAC, I think, also in the next day, because we have the IP5 in which will be presentation and discussion. So we will talk about freight later on. But I think this is a good example also of the transition between the two programs. So now, where we start to discuss about Europe's Rail, as I said, it's not a breaking point. It's simply an evolution of from Shift to Rail to Europe's Rail. This evolution is in line perfectly with the evolution happening in European Union, where the focus has been more and more on addressing the climate change impact and the consequences of it, with the introduction of the European Green Deal by the President von der Leyen, that after became more evolved in the different elements of the policies of the European Union, and one in particular, the Sustainable and Smart Mobility Strategy, that is linked on how mobility and transport will have to evolve to become sustainable and smarter. And if you look at this document, I think it's quite interesting to see that the sustainability that is referred to rail is not a sustainability that is linked to the fact that the rail has to become greener and greener and greener. Today, rail is green, is sustainable, well, unless you walk or you take a bike. And yes, we need to do our due diligence, because there are a few elements that we need to address. First of all, we have still fossil fuel trains, so largely diesel trains. We have still energy consumption that can be, so energy efficiency can be substantially improved. But what is appear clearly from the Sustainable and Smart Mobility Strategy of the European Commission is that rail is the key agent of the overall achievement of sustainable transport and mobility. Because if rail performance and cost efficiency, cost effectiveness are matching new ambitions that are designed in the strategy, we can support the other modes of transport. We can work together with other modes of transport to reduce the carbon footprint of mobility and transport, and ensure that we maximize the performance in the interest of the passenger and the logistic value chain. It is clear that the current situation is not sustainable in the long term. And while other modes of transport, they need to make a full path to become sustainable, compared to today's situation, and we see a huge amount of progress. Today, rail is the agent already available. And in order to make use of this agent, the performance change requested to rail is the key levy that we need to consider. That's the basis on which we have designed Europe's Rail. And now what we have translated, because these are all nice words, but what is the concrete action that are going on? Well, we have designed Europe's Rail with this objective to change the performance of the system, transform rail system. First of all, looking at the system. Rail is a system, is an integration of different component systems. And in order to be able to manage this type of system, you need to have a full understanding of it. The definition of an architecture would allow to define modular elements that are combined together to increase the performance, and on this basis also to review the operational concept behind it. Rail has been operated, and this is operated with operational concept going back to the past, although we have digitalized a different element. But digitalization of existing operations is not simply, it's not nothing else than simply to do what we are doing today with the computer. And this is not the objective of digitalization. is we need to rethink how we want to operate the system to maximize the performance and take advantage of the digitalization and of the automation. The system pillar is there to bring together the sector beyond the membership of the Europe's Rail Joint Undertaking, exactly to achieve this type of target. The second key pillar is that the innovation pillar. The system pillar define together a sector level, concept of operation, system architecture, modularity, the concepts that are underpinning the overall engineering of the rail system. The innovation pillar is there to research, validate, demonstrate, and correct in an iterative process, together with the system pillar, the area that need to be tackled in order to achieve the transformation we're talking about. And it's not a surprise that we are referring to 5 main areas. The first one is the European traffic management, managing the European network as one network. The second one is the full concept automation and digitalization. And please don't refer to automation as the fact that we take away the human factor from rail system. It's nothing to do with this. Automation is the performance of the rail system. Automation is increasing the efficiency and cost efficiency of the rail system. And the only way we achieve automation and digitalization is with the involvement of the people today working in the rail system. The issue we have in rail, and as well as many other mode of transport, is that we will be lacking staff working in the future year. How many people will be having in 2030, 40, 50, ready to be between 2 wagons to screw them together? So automation and digitalization are really the elements that will allow to ensure that during the future year, we transition to more added value function, so that the current interfaces, human-machine interfacing, and vice versa, are properly dealt by. On the contrary, I think in the future, we will have to think about how the interface will be between machine and human, because the human will be there to supervise the system, intervene when the system will not work. The third area of action is clearly infrastructure and energy, and all the aspects in relation to the energy, both in energy cost efficiency and efficiency, but also in terms of every solution for traction, moving away from fossil fuel. And clearly, infrastructure still remains one of the key components and cost driver of the life cycle cost of the rail system. Finally, 2 areas of action that are of extreme attention. Once we already mentioned, and that is one of the examples is the rail freight. Today, 17% of the goods are transported on rail in Europe. Combined transport is a real opportunity in front of us, together with single wagon loads and block trains. But what we need to look at is that today, any ship that, to make it clear, any ship arriving to a port with 20,000 container, if largely is transported 50% on road transport, where possible, the remaining 45% on barges. These are figures from the Rotterdam port, and 5 to 10% on trucks, on rail. So this meaning that if you take 50% of 20,000 container on road, meaning you have 10,000 container, you make the mathematics. I think we are talking about at least 100 kilometers of road transport occupied for each shipping arriving. This is a reality of today that we need to address, and we need to address with the road transport. And this is exactly what we need to do. And this is the concept that Giorgio mentioned before about also synergies and how we combine together the transport. And finally, the last area is that we have big ambitions, and I think the Council adopted the new maps of the 10T corridors exactly, I think, on the 5th of December. And we are making a study that will be published soon about the high-speed network in Europe. All this fine, but we need to connect community. We need to connect people. We need to connect the region to the major hubs where there will be transcontinental flights, there will be the connection with high-speed network or urban network for urban mobility. That's the key element of this regional rail. And finally, if we do the system approach, if we do the innovation approach, but we don't deploy meaning we don't ensure a coordinated deployment European level, nothing will happen. So now in the next slide, we will look at the governance. As you can see, the final decision-making body in the Europe's Rail Joint Undertaking is the governing board, where the European Union has 50% of the voting rights, and the rest of the voting rights are shared between the founding member. And clearly, we have different bodies like the System Pillar Steering Group, that is a key advisory body for all the aspects in relation to the System Pillar, that has to take the key decision, bring together the sector for final the decision-making process of the governing board. But also I would like to highlight the relationship that is really fundamental with the state representative group, because rail is building upon the national system and the national decision-making, and especially with the European Agency for Railways as a system authority for ERTMS as for interoperability, safety and security. These are the key area where we are working. You can see here our founding members, and that are the 25 founding members of Europe's Rail, together with the European Union. And these are only, let's say, the major player in Europe in the rail system. And when I look at the participation to our projects and the first call 2022, we had more than 200 different entities, single entities participating in different manner, without counting now all in the gap preparation phase. We have seen a lot of actors involved in addition to the next one. So we go now to the next slide, please. And we, I think I can give the floor now to Giorgio, who will go more in the technical part of it, and explaining a bit more the structure we have in Shift Rail from the project point of view. Giorgio, if you would like to continue.
Thank you, Carlo. Indeed, I would like to speak with the engineers and the researchers that are on you. And starting with this slide, because well, some of you have already heard me or Carlo already saying this several times, but is of a key importance. All the research innovation that we are doing should be driven by serving the user first. And this is also linked with our motto in Shift to Rail to make railways an everyday mobility. This is only possible if we touch the final user. So this is valid not only for commercial activities or commercial colleagues that, of course, needs to target that in their work, but it starts from the design of the system, and it starts from the research part of it, because we really need to put, let me say, in the back of our mind how this is going to be useful, how this is going to be used by the final users. So this is just a message that it's quite obvious, but I think it's important to reiterate from the very beginning. Also in Europe's Rail, we are going to try to involve the user as in every project as since the beginning of the activities. And because we would like really, as I mentioned before, to bring the solutions at the end on the ends of the European Union citizens. If we go to the next slide, you can see that also this is a slide most probably for the engineers, but those especially to attract those that today maybe are not yet convinced that the future is rail. And especially the younger generation, because we need to bring inside the rail system all the brilliant minds that today are looking into a different way of applying technologies and especially using digitalization for this. The rail system, if you look at it, it's the perfect environment, is the perfect test bed for playing with digitalization. Why I'm saying this? Again, probably obvious things for many of you, but sometimes it's good to put that on paper. Let's remember that rail is a network, rail is a system, rail is supervised, rail is predictive. All of those are the key ingredient to make a digital transition and to make use of the digital functionalities that we have seen, unfortunately, during the pandemic also, but that were very useful. Well, the example is also today, we're using the digital means. But also something else to attract everybody, rail is green. So Carlo mentioned it. It's already the next generation sustainable system, but we need to make it next generation as well. And all of this, what will allow us? Will allow us to play with digital twin, with data-driven process, with system management and interoperability, with using autonomous decision. But all of these, of course, needs to be integrated together. And how do we do it? So if you go with the next presentation, this is how we have designed, let me say, our overall program. And you can see that this is how the different structure of the Europe's rail program is implemented. First, the EU regulation that define our aim and objectives, the master plan that define the key priority areas where we need to focus, and the Europe's rail multi-annual work program, where I will focus in the moment, which is defining the way how the European Union has designed its research and innovation activities in rail in order to achieve the objectives being defined before. And then in terms of implementation, the way how Europe's rail is working is that we have work programs that implement the multi-annual work program. And these work programs are published on a regular and a yearly basis on our website. Our work program, and this is also a change compared to Shift to Rail, are multi-annual work programs, so they cover more than 1 year of activities. And this will also facilitate the work that each of us and you will be doing, and to ensure coherence of results year after year. If we go to the next slide and the next, we can see that we have in the multi-annual work program 7 flagship areas. Those 7 flagship areas are deriving from the 5 priority areas that Carlo presented to you before. And without surprises, you can see a lot of analogies already from the title between all of them. Carlo also mentioned that we have granted the first project today with flagship project 1. So for each flagship area, there will be a flagship project. And in particular, with the flagship projects 1, we're looking in different areas. So we're looking into the traffic planning. So we are really trying to look on how to improve the strategic planning and the tactical planning of the availability of the capacity of the network, but this in a cross-border thinking. So it is not only about improving these strategic and tactical planning, including the timetable optimization at national level, but looking at how it integrates internationally at European Union scale. And all of these we will integrate, of course, simulation, data-driven operations to make sure that we can have an efficient system. After the planning, there is the operation. So also in the operation, in flagship area 1, and in particular in the upcoming year, we will look into the traffic management. And into the traffic management is, of course, about how do we link the different TMS system in terms of processes, one with each other, because it doesn't exist one single traffic management system today in Europe. So we need first to look on how do we connect all of them. And by doing that, we can improve the system resilience and the system efficiency in case, for example, of disruption during operation. But also we need to look on how do we improve the operations in the everyday traffic management system. And for this, we have technologies also coming, and you will see later on from the Shift to Rail research and innovation activities, like using ATO functionalities. And ATO functionality, we have today the GOA2 that will enter into the TSI, and we will work later on, well, we will continue to work also on higher grade of automation and higher automated decision functions. The third layer that we will be looking into flagship projects 1 in the coming years will be the mobility integration. It is important to look on how rail, again, can serve the customer, and rail alone cannot serve it by itself. It needs to be integrated with the other transport modes. So we need to deliver a complete system and a complete seamless solution for rail-based mobility. And for this also, it will set the basis, I think, for a big revolution in the traffic management system that will be a traffic management system that looks into anticipating the demand. So looking towards more a dynamic type of management of the traffic management system, of course, thanks to the ability to process data almost in real time. And the last layer that it is linked with the flagship project 1, and it is not part of flagship area 1, but is part of the transversal topic that you can see on this slide. We have integrated it in one single project, but the transversal topic, it deals with all the digital tools that will allow the system, and not only tools, but also models, and also data spaces that will allow all the systems and all the innovation to make the best use of this new digital reality, and in particular, the transition also to simulation through digital twins. The flagship area 2 will also have a flagship project this year. Now, if we stay on the previous slide, this flagship area 2 will work on different activities in the upcoming year. First of all, as I mentioned, develop further the automatic train operations to a GOA level 4, unattended train operation. And for this, there is plenty of underlying technologies that still needs to be fine-tuned, like a perception system, like remote driving and all of these, and especially needs to be tested in an interoperable way across Europe. We need also to make sure that we are having optimized headways, so that we are making sure that the new generation, in particular of ERTMS, is allowing trains to run closer together. And running closer together, all of you knows what I am talking about. It's mainly about a moving block, but not only. It's also looking into together. It's a system, again, linking together with train integrity, looking together with train positioning. And there we can also find the synergies with other activities and innovation, maybe in shifting the way how do we position the train compared to the current technology. Other enabling technologies will be looked at, and also other innovative operational solutions, like, for example, self-driving wagon. So really looking into more the innovative aspect, but without forgetting the operational part. The flagship area 3 will also have a project, a flagship project, and these flagship projects will look mainly into how all the asset management is also linked and can feed the traffic management system. Today, this is really not managed as one, but you can imagine when you want to optimize a traffic management system, you need to have access to all the data concerning, for example, the planned interventions that are in the infrastructure or on the rolling stock. So this is an important component. Also, the idea is to look at a more holistic approach, the asset management. So to look both from the rolling stock perspective and from the infrastructure perspective. Those two assets are of key importance, but they share actually in the digital transition many of similar tools, in particular, for example, for predictive and preventive tools for asset management, and how do we link that with the real operational intervention into the systems, linking that, of course, with the maintenance. And all of these will be heavily supported by simulations and therefore digital twins. The flagship project 4 will flagship area 4. So we also have a flagship projects, and the flagship project 4 will be looking into the energy management as a whole in rail. We have a lot of opportunities still to decrease the energy consumption or optimize the energy consumption of the rail system. The shift to rail solutions are part of this possible achievement, but we will also look at other activities like eco-designing activities. We'll still further look into the alternative propulsion systems, and these together in synergies with other joint undertaking and other partnership and initiatives of the European Union. But also we will be looking into ways to optimize, in one sense, the rolling stock. So greener solutions on all the single subcomponents, and also greener solutions that attract the customer, not from the greening perspective, but also for wanting to take the train. So, for example, interiors modularity solution for attracting the customer. Let's not forget that the first interface to the customer is the station. So we need also to look on how do we optimize the station as a hub also for this greening transition. The flagship project 5, it will also start this year, part of flagship area 5, and it will look mainly into how do we bring the digital automatic coupler into the rail system in terms of operational functions. So a lot of tests will go around in the upcoming years, including looking forward to automated shunting operation, automated wagon inspections, and automated yards operations and the different equipments that goes together with it. But we don't have to forget that it's not only about technology. We need also to think about processes, and the processes, it's key in the freight. Freight is by design and by international, and today we have some potential barrier that all of you that do freight operation, you can see it on a daily basis. Again, here we can use digital means in order to push the seamless planning and the dispatching, and also to push the intermodal integration in the system and prediction of the demand. So you can see also here the link with flagship area 1. Then flagship area 6 will also have a project this year, and will look into how do we combine all the different innovations that have been achieved in shift to rail, are undergoing in Europe's rail, and are maybe already available on the markets, the famous COTS, that we can use to improve the rail regional system, but as a system. So we're really looking into the integration of operation, controls, communication, and also, for example, rolling stock. We're also looking into are there ways to lighten the rolling stock, making it more competitive as well in the freight areas. In the regional area. Let's remember that in Europe, especially, we have already a huge network, and especially we have regional lines or capillary lines that are often underutilized because also of the cost of the railway system. So we are looking into that. Flagship area 7 will not have a flagship project, but we will have a series of different projects that we have launched in our second call. The second call is still ongoing until the 14th of December. And it will look into innovative approaches for guided transport modes. So we're talking about magnet technologies, hyperloop technologies, new ideas of careers that share common infrastructures between road and rail. So these type of innovative and groundbreaking ideas, which are also important to the rail system and to look into how all of these correlate with a more sustainable transport mode. And finally, the exploratory research activities are other key activities of the innovation pillars. Why? Because we need to look into the way, how do we design, well, what are the future promising technologies on one side, future promising research, also looking at the basic research where needed, and also pushing the, let me say, researcher and PhD to come out and work within the rail system. So also this is part of our second call that is currently ongoing. If you go to the next slide, you can see also the system pillar activities. Carlo already explained why we need to have the system pillar. It is an open platform. It goes behind the membership. It also goes behind the pure researcher, because it's also targeting those that would like later on to operate those research into their system. But we need a full alignment. And so we really need to work on the concept of operation, the concept of modularity, and all of that will fill into future standards, future regulations. And for this, we're also closely working with the European Union Agency for Rail. The Commission is at the heart of the system pillar, because we would like, together with our colleagues of the Commission, to make sure that the new system is designed responding to the single European railway area and responding to the objectives of the Union that previously Carlo presented to you, and of Europe's rail, of course. We have designed the system pillar in different tasks. We will have a task 1, which deals with the system as overall. And then we have already identified 3 other tasks, one dealing with the traffic management system, one dealing with the CCS system, and one dealing with the DAC. And again, the idea is to define the architecture for these to work together, the engineering rule, the operational rule books, and all of these that will, at the end, allow us to integrate all the innovation into the system and operate as one, also reducing the number of different versions inside the rail system that only create also some kind of barrier for the evolution. If you go to the next one, we can see how do we intend to implement the Europe's rail program in this case. So you have already heard me talking about the implementation of the innovation pillar activities in calls. The first call has been already launched and closed. The second call is ongoing. The second call deals with the exploratory research activities and flagship area 7. And every year we will launch also this type of exploratory calls topics on a regular basis. On the flagship area 1 to 6, plus the transversal topic activities, we have a more multi-annual kind of approach, as I was mentioning to you before. And for this, we are planning 3 waves of calls. The second waves for the flagship areas that will generate flagship project is planned around 25-26, and the third one in 2027. For the system pillar activities, we have launched we have implemented it through a framework, a procurement process, and therefore we have today in place a framework contract with all the activities that will be launched in function of the different needs. And then lastly, the deployment group, that it's also a key activity that will allow us to kickstart the reflection on how do we integrate all these innovative technologies that and the solutions that have been demonstrated into the system at the higher TRL possible level, how we migrate that and how do we deploy that into the system. We go to the next one. You can see also how do we implement it, how do we monitor this implementation? Of course, we are following all the classical monitoring derives from the application of the different rules we have to apply with. But on top of it, there are also other monitoring processes and synergies that we want to put into place. I will not go into the detail in the interest of time, but for you to know, the idea is really to look into all the different activities of the program on a, let me say, output-based approach, where we are looking into the content, if the content is going into the right direction, not only into the progress of the activities, which is another aspect, of course, of the monitoring activities. In the next one, you can see that in our master plan, we had defined a series of key performance indicators. There are many more that will be monitored at the project level, but those ones are the key that we have identified, having a direct link with the 7 impact areas that have been defined in our master plan. The first impact area deals with customer requirements. You can see it's really about the users at the end. The second, improve capacity. Third, reduce cost. 4, sustainable and resilient transport. If we go to the next one, you will see the other impacts, which is harmonized approach, so creating interoperability, reinforced role of rail in the transport system, and improved, you cannot see there, improved the competitiveness of the rail supply industry. For all of these, we have key performance indicators that will be monitored and coming out from the implementation of the projects and from the implementation of the system P. We go to the next one. We will have, on top of this annual monitoring of key performance indicator, we will have calculation being made 3 times during the duration of the Europe's Regent undertaking on what is actually the societal impact of all of this. So not looking only about technical means that speaks maybe to engineers, but don't speaks to the society and possible also decision makers. We need to show the impact that our activities bring to the societies. And so we will work also on that. And especially we want to calculate that after each round of the demonstrators that will showcase what actually can be achieved.
Thank you very much, Giorgio. And we are perfectly on time. It's 9:59. So I think Javier, that is our senior program manager, that will be in charge in the future of different area, but still now carry the responsibility for the IP1 in the Shift to Rail JU, while in the phasing out. Again, Ibanez, the Irigoyen, is ready to start and take over from us. So thank you very much, Giorgio, for this morning. We will continue with the current link, so stay tuned and don't disconnect. And Javier, I think you are there, ready to start.
Indeed, Carlo, thank you. Thank you very much. I hope all of you can hear me well. So we start the session. One minute. So before starting the session on IP1, just some housekeeping rules for you to know that to ensure a smooth session and to avoid any technical difficulties, we have disabled the microphones and the cameras for the participants, but you will be able, of course, to participate, and we want to hear your thoughts on how the session for IP1 is going on. So please don't hesitate to write your questions in the chat, so we will be monitoring this channel of communication, and then later on after the session, as you could check in the agenda, we will be addressing all of them, addressing the questions to the speakers and to the technical leaders involved in the session today. Please note that all sessions are recorded, so They will be available in the Europe's Rail website in the upcoming days. And then to be able to join the next session, you just need to go into the links provided within the agenda. The links are embedded in those slots, so you will be able to follow the 3 days of the Innovation Days from Europe's Rail, following this planning we have created for you and to make it more easy for you to access the sessions. We would also like to invite you to comment on how we can improve for future events. So you will have a dedicated survey that will be made available also on our website as from Friday, 9th of December. And like that, we will hear from you on how we can improve future events and preparations. And then, of course, you're also invited to subscribe to our mailing list by visiting our website. And the link has been also a link will be also provided with the main takeaways of the session these days. Okay, so as Carlo introduced me, I'm Javier Ibáñez Erigoyen. I'm a senior program manager at Europe's Rail, and as also mentioned, I'm dealing with the coordination on the innovation program 1, which is dealing with the activities on future rolling stock and all the subsystems related to that. As you may know, the work in Shift to Rail within this innovation program has been following or has been addressing different subsystems such as traction, train control and monitoring systems, new generation car bodies, running gear, new braking systems, innovative door and accessibility topics addressing these technical demonstrators, as well as train modularity in use and heat, ventilation and air conditioning systems in the activities provided or addressed within the IP. Today, as you could see in the agenda, we will be highlighting the activities of 4 specific technical demonstrators. That means we are going to talk about the next generation car bodies, new innovations in running gear and devices developed within the programs of Shift to Rail, and then we will also touch upon innovative doors and accessibility and train modularity in use. And in order also to show the collaboration that has been set between the open call projects and the members of Shift to Rail, we will give the floor in the last part of the session to 2 open call projects that will be presenting the results of the activities they have done within these projects, Next Gear and Carbodin. And of course, based on that, and in order to address also the sustainability issues and energy topics, we will be highlighting how these projects have contributed to these activities in those specific technical demonstrators. In order not to delay too much, and as we are just in time, I will give the floor now to Javier Goicoechea. Javier Goicoechea is the Innovation Program 1 coordinator, and he will be also addressing or presenting a bit the activities we have been touching upon this innovation pillar. And Javier, you can take the floor as soon as you are ready. Thank you very much.
Yes, thank you, Javier. You know, energy consumption
You have to unmute yourself, Javier. Yes.
I am unmute. Can you hear me?
Go ahead.
Can you hear me?
We cannot hear you here.
Hello? People can't hear me. Maybe it's you, Javier. Anyway, so if people can't hear me, let's start. Okay, I was saying that energy consumption is an extremely important topic nowadays. You know, energy has become a precious good, and energy saving should therefore be the objective of all of us. Railway can contribute significantly to that goal, being the most efficient transport mode. As mentioned by Carlo and Giorgio this morning before, railways is the key agent in improving the sustainability of mobility of passengers and goods. IP1 has been working in the last years to even improve more the energy efficiency of the rolling stock. So a good example is the introduction of silicon carbide semiconductors in the power electronics of traction, and auxiliary converters. But efficiency goes beyond that. And other innovations, some of those being presented later today, will contribute even further to reduce the energy consumption of the rail vehicles. However, this has another perspective. Considering the energy efficiency of railways, the overall energy consumption for us, the European society, can be also reduced by attracting travelers to railways, fostering, therefore, the modal shift. This can be achieved not only through specific policies, so for example, reducing the cost of the tickets or even making them for free, like in Spain nowadays, but also by making rolling stock more comfortable, more reliable, more accessible. This is what IP1 is also about, and we will see later. Weight reduction is an important contribution in all aspects. On one side, lighter vehicles imply less energy consumed in accelerating. But also, if the weight reduction allows carrying more passengers or goods, the needed energy per passenger or kilogram will be reduced, contributing to the overall goals. In that sense, I would like to give the floor to Andreas Schäfer, the coordinator of our IP1 project Pivot 2, and he will provide us some insights about the results of the TD13 on lightweight car body shells. So, Andreas, the floor is yours. Please unmute and show yourself. Thank you, Andreas.
Yes, good morning, everybody. Thanks very much for this kind introduction. I hope everybody can hear me well. As already said, I'm going to present the next generation of car body shells investigated in our Pivot 2 project. I have the pleasure this morning to speak on behalf of Eduardo de la Guerra. He's not available today, but he is actually in charge as TD leader of the new car body shells. So next slide, please. Basically, where are we coming from? Most of you know, today we have lightweight metallic structures for the car body. Basically, this is a shell containing passengers when traveling by train. Here you see two examples of these lightweight structures. Basically, it's made out of a metallic sheet and profiles and welded then together in a efficient process to have these car body shells, but of course it's always possible to make it lighter. And in our project Pivot 2, we were looking into composites to deploy in the shell to achieve weight reduction. Next slide, please. As already mentioned, why we are doing it. So every saved kilogram is worth doing it, either if we look directly into the effect having this reduction when having less energy consumption due to the fact that we have to accelerate and brake, less mass in the train set. And of course, there is another effect on this. If we assume that we have a train which is lighter than another one, then we can, it might be possible to introduce smaller traction systems because it's not so necessary. So it's not necessary to over accelerate, and as well we can reduce braking systems as well because we have less mass to brake. The other and side effect of this would be that we can make the operation more efficient due to the fact that railway access fees would be reduced depending on the model that the infrastructure manager is using. Of course, the other possibility to reduce energy consumption is looking at if we look at the specific energy consumption used to a passenger transportation per kilometer, then if we invest a saved kilogram in the possibility to carry more people, then the specific energy consumption will be reduced. And this, at the end of the day, leads to a more efficient and more attractive railway. So next slide, please. So in Pivot and in Pivot 2, we looked into the possibilities. Pivot was the first project dealing with the topic within IP1. There we specified the needs for such a car body and how it should look like. We did some research on material and processes, characterized everything, and in Pivot 2 then we continued these by developing 3 demonstrator I'm showing you right now with the calculation methods as well as the necessary toolings. And then we are going on right now in testing these components. Next slide, please. So here we show you the 3 demonstrators within this package. So on a component basis, or let's say sub-assembly basis, we were looking into an underframe piece at the end of a railway car. Then we have another one based on a high-speed vehicle, the end module of intermediate high-speed car. You can imagine here we have the entrance systems. Here we have the gangway to the next car. And underneath we have the rather complicated end coupler module for the coupling of 2 intermediate cars. And last but not least, Talgo went into the development of a full coach of a high-speed train set. This is a 13-meter, roughly 13-meter long high-speed car body, which is under preparation. The target for these weight reductions we already achieved is for each component, or let's say for each module, it's 20 to 30% weight reduction, which is rather important. Next slide, please. So here I can show you a couple of sub-assemblies of the various demonstrators. For instance, here you can imagine for this end piece of the commuter car, and here are other sub-assemblies as well. Next slide, please. And then we see in the next slide, please, the complete car. Yes, here we are. So this is the final assembly of the full car body. As I mentioned, 13-meter long. Here we have the entrance doors and the window section. This is made then by components made in an autoclave. Then we can show you in the next slide. I wrote down a couple of things materials and processes we used. So you can have a look here. And the next step will then be on the component level, various tests. And here, this is an example of another metallic car body, very simple to the composite one I showed you in the test rig, where we do the compression and other tests according to the relevant norms need for railways. A very important point, introducing new materials is the question of homologation and standardization. We all know railway people are very conservative people, which is very important, of course, due to the fact that we carry a lot of people and we want to have very reliable systems and safe systems as well. So standardization is a very important point, and these new materials has to, of course, cope with all the relevant requirements in the rail system. To begin with structural strengths, fire resistance, and so forth. And all these things are covered in standardization work, and the new materials are brought in the various standardization bodies. So from that point of view, this is in a nutshell what I wanted to show you on behalf of the team. Here we have a very short overview on all the project partners in Private 2, which I am very proud to be the coordinator and hopefully bringing this complete project then to a successful end by the mid of next year. Thanks very much for your appreciated understanding. Thank you. So if there aren't any questions, there's another Q&A session at the end of this session. So then I would suggest to go to the next demonstrator, running gear. But of course, this is up to you, Javier.
Thank you very much, Andreas, for your presentation.
So then, Azia, I think
Okay.
you're there. Please
I
go
will
ahead.
start now. So, Azia Alonso from CAF, I'm going to show you the first part of the technical demonstration 1.4 running gear. Next slide here, please.
It seems there are some technical issues in Brussels, so I hope they can solve them. I don't know what's going on. Some patience. I ask you, please, some patience. Can someone in Brussels?
Asier, can you please go ahead?
Yes. Can
Yes.
you hear me?
Yes, we can hear you well. Yes.
Okay.
Please go ahead. Thank you.
So, can you go to the next slide, please? Okay. Then here we can see very briefly the relationship between TD.4, 1.4, and the rest of the Shift to Rail and Europe's Rail initiatives. We can see that mainly the work of TD 1.4 has been focused in Pivot 2 project, but we have had a strong relationship, work together with several open calls like next gear and gear bodies, and also with some CCAs like fine-tune and impact. We wanted to show that obviously the work that has been done in TD 1.4 is not going to finish in Pivot 2, but it will continue in Europe's Trail initiative. For example, in the flagship Area 1 motional, we have a lot of things related to digital twins. In IAM4Rail, there are a lot of things related to asset management and so on. Then, can you go to the next slide? Within TD 1.4, we want to show 3 innovations. The first one is the health monitoring system based on digital twins. The idea is to develop a wayside system that allows us to analyze just with one system the current status of all the fleet. And the interesting thing here is that it has been developed using or based on a digital twin. In this slide, we can very briefly see how this has been done. In a first step, we have been constructing physical models, detailed models of the phenomena that we want to analyze. The idea of these models, the purpose of these models are various. On the first thing, it allows us to understand the problem, how the different problems affect the variables that we can measure, the signal of the accelerometers, the signal of the strains, and it allows us to analyze where to put the sensors, where we can have more sensibility, and so on. Also, this model allows us to analyze how we have to do the signal processing, the requirements of the sensors, and define key parameters of the problems. And finally, the model allows us to fit machine learning models. As you know, we don't have a lot of signals in order to fit the models, the machine learning models with defects. I mean, we don't have signals of vehicles with problems in the primary suspension, or we don't have a lot of signals with flats. So these models allow us to obtain build signals, fake digitally constructed signals in order to fit these models. In the next slide, we can see that this wayside system has been already installed in a real track in Metro Bilbao, and currently it allows us to analyze the status of the primary suspension, if we have flats, if we have ovalization, if we have out of roundness. And as I have said, the signal has been installed, and we have validated the results of the new wayside system with experimental laboratory tests. So when we have detected a problem, we have taken the key parameter, for example, in the primary suspension, we have taken the primary suspension and we have analyzed this primary suspension in a laboratory with laboratory test in order to check if the results that we are obtaining with the wayside system are correct or not. And finally, in the next slide, we can see how that although most of the calculations are done in the wayside system, the key parameters, the key results of the wayside system are sent to a data pool in the cloud, and we have constructed a front end in order to easily visualize the current status of all the fleet. So with this, I finish the description of the first innovation, and I give the floor to Ricard, that will continue now.
Yes, hello. My name is Ulrika Persson, representing Trafikverket and KTH in Stockholm. I'm here representing the TD 1.4 instead of Paul Butcher Alstom, which is not available today. Please advance to the next slide, please. I'm going to show you two examples of lightweight running gear structures, both being single axle running gears. The first one comes from Talgo. You see to the left where how this lightweight structure, or it's actually the normal weight structure to the left, and you see to the right, you see the lightweight structure made in plastic material, a reinforced plastic material, which have saved, like 45%. It's a combination of the plastic material, and on top you also see them lightweight metallic structures, but in total the same is 380 kilograms, and representing 45% of this frame for the single axle running gear. So please advance to the next slide. Talgo has produced two prototypes. The first prototype was intended for static strength test, where they tested it in exceptional loads, service loads, braking loads, and 30% increase in loads. The second one of the prototypes was subject for fatigue strength testing, 10 million cycles, 6 million in normal, 2 million cycles in increased, and 2 million cycles in 40% increased load. And after that, they also performed static exceptional load test after this 10 million cycles, and also performed ultrasonic inspections, and everything was found to be okay. And here they have referred to an EN standard for bogies, the 13749, which they used as the only applicable standard today. So please advance to next. And this runs into the issue about the standardization. This is the same picture as we saw for the car bodies, but this is equally important also for the running gears, that we find a way to also homologate the new materials in running gears, and as well in car bodies then. So please advance to the next slide. Next example is a cooperation between Pivot 2 and NextGear. And NextGear, you will hear later on details coming up also, but I will give you an overview. Cost and weight reduction, introducing single axle rears in metro trains. There is an energy and maintenance cost constitute a large part of the recurring cost for railway operation, and the vehicle weight impact both the energy consumption directly and the need for tamping of the track. In the projects Pivot and Run to Rail, and further into Pivot 2 and NextGear, all parts of the EU-funded initiative Shift to Rail. A single axle running gear with composite was proposed for metro vehicles, and a little bit of the story you can see below, where you have the Schienenbus from 1950, which was certainly a low cost and low weight vehicle, but unfortunately had some deficiency in means of poor comfort and large wear on wheels and rails. That led to the design, the standard design, I would say, today, where we have introduced bogies and a much heavier vehicle, so we got the good comfort and we got the low wear on wheels and rails. But unfortunately, we also got the high cost and high weight. So now we would like to turn back the watch again to the innovative vehicle, where we get the low cost and the low weight, depending on the setup of the vehicle, but we try to mitigate the deficiency in comfort and performance in curves with active technology. So now we're going to go on to the next slide, please. Yes, and a little bit about the history, how we can assume that we reduce the weight in such extent. We're going from like 104,000 kilograms to something like 80,000 kilograms. And everything in that is related to the change of the running gear. If we see the top view here, you see that the frame is located. Red is the frame of this running gear. They are now located to the right. You see that it's located inside the wheels, making the frame more compact. And the wheels axles become shorter and also lower in weight. The anti-roll bar is incorporated in the frame, so it's part of the frame nowadays. And one step is eliminated, and the remaining step is a simple coil spring. So it's a very simple solution in the base. This leads to weight reductions, allowing less wheel axles to carry the weight of the train. Like 6 bogies, that is 12 axle, can be replaced by 10 single axle running gears. So this is the whole story, where we started from. To make that possible, we can go about to the next slide. Yeah, that's right. We need 2 things. First, we need to solve the ride comfort, and that the ride comfort is related to that we only have one suspension step. It makes it very difficult to get a good ride comfort. And the solution here to add an active system, it means more or less replacing the conventional shock absorber with an actuator, small size actuator. And this low force suspension intended to improve the ride comfort. You can also see the influence here that the diagram showing the limit of the ride comfort is 2.5. I calculated as NMV comfort limit. And you can see the diagrams showing the passive vehicle, and also this is statements showing the controlled vehicle. So now we're meeting the target on ride comfort. There is also another important part is that we need to control the wheel set steering, and that is also part of the pivot 2, but not taking up here. There will be some details on that in next gear presentation. So please advance to the next slide. The cost reduction is not directly related to the running gear itself, but it's also related to that we can reduce the energy consumption, and the reduced weight will reduce the energy consumption with about 5,000 euros per year and train set. It will also reduce the track maintenance about 10 kilo euros per year and train sets. And the improved curving performance, which is the active steering that comes in hand, will also reduce the energy consumption, the wheel wear, and track maintenance. In total, we get a cost reduction of about 50,000 euros per year and train set. So this was the last picture in my presentation. Thank you for listening.
Thank you very much, Richard, for the presentation, for the insights on the activities being done on running gear topics. We are now changing and for linking these important actions on how energy reduction and energy consumption is linked to those activities within the project. We will go a bit more into depth later on. And now we change a bit topics. Now we move somehow. We're trying to access the train at the moment. Thierry Montanet is the TD leader for the innovation doors activities and entrance systems within Shift Rail, and he will give us some insights on which are the activities that we have been also developing within the projects, and later on will be also Robert touching upon the interiors and the modular interiors that we have been also working on. So Thierry, thank you for joining us today also, and the floor is yours. So you have the go right now. Thank you very much.
Okay, thank you, Javier. So I present now the subject that have been addressed during the TD 1.6 of about innovative doors. So what are the purpose and the target of the project? So can you next? Okay. So different topics has been addressed during the studies, because the first target is to improve the accessibility to the train. It is also to improve the functionalities of the access system to improve the safety, but also to improve the operations. For example, we want to detect the platform and so on. So another topic is the lightness, because it is an important topic. We will speak at the end of the presentation about that. Of course, main constraint is to optimize the cost. And another target is to improve the comfort. And for the comfort, we speak about sound and thermal insulation. Next, please. So in the TD 1.6, a different project has been involved. The first one is Mat4Rail. So next, please. And Mat4Rail works on the innovative doors with a long-term innovative design of the doors. The first one is studies works about composite, the composite, and they have proposed to use a core that have been machined and use also SQRTM process to design and to manufacture the door leaf. This in Pivot 2, after we use a very close process. So it is interesting that researcher for long term has made the same choice that we have done in Pivot 2. Second interesting proposal is to use additive manufacturing because they propose that the core of the door leaves are manufactured with lattice structure in plastic reinforced with fiber. It is a long-term proposal because today we cannot with this process use in the trains because we cannot manufacture the size of the door leaves compliant with fire and smoke constraint. So it is a long term, but interesting to have in mind for future development. And the first and the last proposal was to is a proposal of a new design of the frame of the leaves. That means that instead of using aluminum profile, they use bending the skins, coils, and so on. So it is also interesting, but this proposal does not solve all the comfort features because with that we don't improve a lot the thermal insulation. Next, please. About accessibility, there is a collaboration with IP3. And in IP3, mainly with the Fair Stations project, which focused on platform-based system to improve the accessibility to the train coming from the platform. To improve that, they propose a ramp, if I can say, in order, for example, people with using wheelchairs can access to the train vestibule without gaps or offsets, and this platform will be installed on this ramp. Sorry, will be installed on the platform. In addition of that, Fair Station has written and proposed what are the user needs, in fact, to improve the accessibility to the train. So that means that next, please, during a pivot project, we have studied a solution to install in the train, no more on the platform, but now in the train, to solve and to reduce the offset and the gaps between the platform and the door threshold. So we propose the concept we have studied is an internal ramp. That means that the floor inside the train is moving, and in addition of that, there is an extension with an external ramp. At the end, we have not developed that system because it is very complex and very cost, with a very important cost, and there are a lot of difficulties to implement such a system inside the train. Next, please. So during Pivot 2 project, we continue the accessibility topics by improving the design of the bridging plate, and also to design a new concept of door thresholds, mainly for sliding doors, that means for metros or commuter trains, which are equipped with sliding doors, because in case we need to use a plate to board on the train, there is an important offset, because to guide the sliding doors, we have in fact, we need to support the door at the bottom part of the door leaf, and due to that conventional design, we have an important offset between the bridging plate and the vestibule. So we have studied another system to solving that issue. Next, please. And the main activities we perform during Pivot and Pivot 2 are dedicated to improve the comfort and the lightness of the door lifts, and that subject has been addressed with a new design of the frame of the lifts and the design of the insulation. So, in parallel of Pivot, the Carbonine project work also on the door lift, but you will have a dedicated presentation after. So next, I don't speak a lot about operational and safety function because the result is not known at this stage. So you will have the result during the final meeting of Pivot 2 project. Next, please. So what have we known about the door lifts? About the metallic door lifts, we have improved the acoustic insulation using a mix of rigid and soft foams, because the rigid foam are a poor acoustic insulation, but have interesting mechanical performances. So at the opposite, the soft foam are the reserve, the contrary performances. So it is interesting to mix rigid and soft foam, and using that, we have increased the acoustic insulation of about 3 dB. About thermal insulation, we have designed insulated pillars using aluminum profile and a core made with honeycomb, plastic honeycomb. And with that, we have improved the thermal insulation of about 19%. In parallel of the metallic door lifts, as I have already said, we develop also composite door lifts made with press molding process. And with that design, we have a very important gain about thermal insulation, 51%, and an interesting weight reduction of about 14%. Nevertheless, the acoustic insulation is not so good with that due to the reduction of the weight. Next, please. At the end, we have different demonstrators. All are based on the same basis. That means we use they are designed for regional train, using sliding plug doors, using a new generation of door operators. And in parallel of the activities of the door lifts, we developed also different plastic equipment like plastic handle, and also what we call high-load swinging arm, which is an interesting equipment which lock the bottom part of the door lifts. So, and with this common part, we designed the metallic and composite door lifts that we have installed first on a train, in fact, but a static train, and we perform also different mock-up to perform the test. Next, please. The results of that is are about the acoustic attenuation. It is interesting. We have an important improvement with the metallic solution, but not with the composite one. About thermal insulation, we achieve for all the configuration the target of thermal insulation, but we propose a different configuration about composite or metallic door lifts, because depending on the market, it could be interesting to optimize more the weight than the thermal insulation of the acoustic insulation. So it is the reason why we propose 5 different configurations. Next, please. In parallel of that, we have made a study about energy reduction, which is now an important topic. And we have performed a life cycle assessment of the door. And the result is that about the energy consumption at the level of the door is mainly due to the distance traveled by the train, the electricity mix that we use, the weight, and the weight of the door. We have not studied the consequence of the thermal insulation because for that we need to build a model of the train, and we have not the possibility to do that at this stage. What I can add is that the opening and closing of the door does not require an important energy. So it is the reason why the main topic that we can address during the project is the weight, and we have done that, improving the weight of the door lifts and the different equipment. At the end, at the door level, the energy reduction is about 16% for the metallic solution, and about 40% for the composite solutions. So thank you for your attention.
Thierry, thank you very much for the detailed presentation and the activities that within the different projects you have been we have been addressing, and also making reference to the door lifts you were showing for the people or for the colleagues that were also that had the chance to attend last InnoTrans.
Yes.
We were able to show the doors over there and how these improvements on the doors without jeopardizing the without making any by making these developments on the solutions implemented are improving those externalities and making them not so annoying for the travelers. So in that sense, thank you very much, Thierry, for the presentation, and for the benefit of time, we will pass now to Robert Dumortier, that is presenting a bit the activities on the train modularity in use on the modular interiors. You will see some concepts here, very interesting. And just a reminder for the colleagues attending the session today, please don't hesitate to start sending questions in the chat. So far, not many questions addressed, so please don't hesitate to start sending us these questions that will be addressed after the project presentation that will come after Robert. So Robert, thank you very much, and the floor is yours.
Yes, good morning. So I'm Robert Dumortier from SNCF Voyageurs. I'm the TD leader 1.7. This topic is about modularity in use, and especially modular interiors, because the target was also between cabin, driver's cabin, and passengers. But today we will talk only for the part passengers. So the main target of this TD was to reduce the global cost of train interiors, specifically for refurbishment, because if we want to be more attractive, maybe we have to adapt to the demand, and so to do more refurbishment than today. And so it's important to reduce the cost of this part of the life of the train. The second target was about the environmental impact, and to have a first step about analysis about an eco-design approach. And the last one was to how to help to evolve the capacity of passengers, but also the services on board. And so at the time, it's the topic of modularity. So next slide, please. At the end of Pivot 2, the main target was technical and economical, and so we have almost divided by 2 the global cost of the interiors, and also the number of pieces. This is important because it's very linked, but it is also linked for the target of environmental impact. And for this, we have built 2 concepts, and to explain it, I will take time to explain the current situation. So next slide, yes. It's not so okay. The current situation in interiors. We have a seat in a passenger room, and if we want to change all the space or only part of the space, and for example to add a bicycle rack for example, we need to not only to change the seat, we need also to modify several pieces. So next slide, please. And each pieces you see in green, it's a new pieces for bicycle rack. So this is the case for each new demand, each new interiors we had. So at the end, it's very costly in time and costly to build. And the target was to think differently and to accept that we have a direct access to the fixation and no more add the fixation system. So please next slide. Yes, so concept one was to attach the equipment to two bars, so a low and high bar, and by this way we have a directly access to the equipment, and we win a lot of time, but we win also to simplify the design of the panels, and so to reduce the number of panels, because we don't no more need to hide the fixation system by other panels, and so at the end it's why we have reduced a lot the number of panels. For the concept 2, so next slide. We have the same logic of design. But in this case, we have directly a beam, and we will fix all the equipment to this beam. So with these two concepts, we have simplified the design. We have reduced the number of pieces, and with this, we have also simplified the molds, and it's why we have reduced the total cost of the interiors. Next slide. Okay, and so if we see all the life of the train, currently we have only one big refurbishment at the mid-life of the train. So we have analyzed the impact of current situation and the two new concepts during all this step in the life of the train. So we have done an LCA specifically for the current situation, said AGC, and the concept 1, C1, and the concept 2, C2. So please, next slide. Yes. So we have worked on two topics. First one was to reduce the weight. So with Aernova, our partner, we have decided to use a lighter material, but easy to build and easy to build also the mold to be done. So at the end, we have reduced by 2. Depending of the concept, and more by 2 for one. And this have a global impact for environmental indicators, and by reducing the number of pieces, we have also have an important impact of the all of the phase of the life, and especially in the use phase and the manufacturing phase. So globally, we have a coherent final design. So we can have the conclusions, please, with the next slide. With an important impact of weight, an important impact for all the environmental indicators, and we keep an attractive interiors and the capability to adapt the interiors to the demand. And because we have only a view of 5 years for the demand of passengers, so it's important to have the capability to answer to this new demand. But shift to rail and pivot was the first step of this new design. We will continue the work in Europe's LGU FR4. About sustainability, and especially to integrate now the component, so the seat, the luggage rack, etc., and to also to show how the circular economy could drive the design also. and maybe and probably push a new way of design for interiors and passengers with new materials, but also probably new finishing. So thanks for.
Indeed, thank you very much, Robert, for the presentation and for the insights on what has been also developed within the Pivot Series projects. Again, I repeat myself, but some of these concepts could also be seen during the last InnoTrans fair. So it was also very many visitors and many people interested on what we are doing within Shift Rail in this topic. So thank you very much. We will develop this a bit later on how this also influences on the energy consumption. I mean, of course, reducing the weight of those components have an influence at the end. So this topic will be also covered by the next two presentations that are coming up, as mentioned in the introduction, in order to show how this well collaboration between open call projects and funding members of Shift Rail in the linked activities on these CFM projects. We have today two projects that are finishing the activities this year. One is next year, in which for which Sebastian Stitcher, the technical leader, will be presenting today, and then later on we will have another open call. But now is the time for you, Sebastian, to let us know how all these outcomes and achievements have been developed, and I think it will be very interesting for the audience to see what you have been doing in coordination with all the entities involved in the project. So please go ahead, and again I invite all of you to please send the questions that we will be addressing after the two upcoming slots today. Thank you very much. Sebastian, the floor is yours.
Thanks. Yeah. Thank you very much, Xavier, for your introduction. My name is Sebastian Stichel. I'm professor at the Royal Institute of Technology in Stockholm, and as Xavier said, I was the technical leader of the project. And as you can see on the first slide, this was a 2-year project, a little bit extended because of Corona, and it ended in February this year. We had 16 partners, and as you see on the next slide, if you go to the next slide, we think we had a good mix of universities, research institutes, and industry. We also had an operator, Metro Madrid, as a vehicle operator, which was quite important actually also for the project. The coordinator was UNIFE, and as said already, the technical leadership was with my university, KTH, in Stockholm. If you go to the next slide, there were 4, you could say, high-level objectives. First 3, very tangible. We intended to work with novel materials and also new manufacturing methods. We worked on active suspensions, both on software and hardware, controllers, actuators, and how to control vehicles. We developed the concept for the wheel set of the future, and all this circled around, as you can see in the center, the next version of the universal cost model, which you can use to evaluate all the innovations that we proposed. Now on the next slide, if you let me first summarize the most important results from the project before I go a little bit more into the details. As an application example for additive manufacturing, we chose an antenna bracket. We designed it, we actually manufactured it, and it was also shortly tested dynamically on a metro train in Madrid, and we achieved a 60% weight reduction compared to the existing component. We also conceptualized, designed, and manufactured a carbon fiber composite bogie frame, which had a 50% reduced mass to a comparable one in steel. We designed a virtual demonstrator of a hybrid metallic composite wheel set, where we achieved more than 60% weight reduction. And we came up with the concept of a 2-axle single-stage suspended vehicle where we foresee a 400 kilometer per meter weight reduction. So you see most of what we worked on in the project is aimed to reduce the weight of future vehicles. And in the end of my presentation, you will also see how it influences the energy consumption of a train ride. The next slide, please. When it comes to active suspension, as I said, we work both on hardware and software. Here you can see a part of a controller, a CL4 controller that was developed, and on the right-hand side you can see a new type of actuator that actually also was built by the company Delna and tested in laboratory. So also here a real component that was manufactured. And to the third slide from this, if you go to the next one. And when it comes to the universal cost model, we designed a completely new user interface. It's an Excel-based tool that will be available for everyone. It included a quite new, sophisticated procedure for damage modeling of switches and crossings, which was not in the first version of the tool. And it enabled us to test the cost implications of the innovations we proposed in the project, and also some other shift to rail proposed innovations with this model. All of this I will talk a little bit more in the coming minutes, of course. So the next slide, please. If we start with the additive manufacturing, you can see on the left in black the original component, an antenna bracket, and then you can see the design stages, and the most right version is the version that was then actually manufactured with additive manufacturing, and as said, actually tested on a metro train in Madrid. And if you go to the table on the next slide, then you can see some of the features. The most important numbers here are probably that the weight could be reduced from 26 to 11 kilograms from the original to the new antenna bracket with additive manufacturing, but also the number of individual parts could be reduced from 17 to 2 parts. And we foresee that this will also reduce the lead time of such a component from several months to just a few weeks. So we think quite promising here. The next thing we worked on, as said, a concept for a single axle, single suspension stage vehicle. The car body is not very futuristic, but of course a real vehicle would have a different car body here. But since this is a two-axle vehicle, of course it needs to be shorter than a conventional bogie vehicle, but also the weight has to be reduced, and therefore we designed a carbon fiber bogie frame for this vehicle that also had the function of the anti-roll bar in the vehicle to save one component. So if you go then to the next slide, here you can see that that's not so important. There you can see that the bogie frame was designed. We did extensive finite element simulations, and then it was actually manufactured by the Italian company Bercella and then shipped to our laboratory, where we did some dynamic testing, static and dynamic testing at it. You can see it also had some metallic inserts here. And if you go to the next slide, as said, we did some static and dynamic tests, and we could see that it fulfilled the requirements, and it also had the properties that we predicted in our simulation models. This is, for example, a twisting test. I said in the beginning that this frame also is an anti-roll bar, and the torsional stiffness was almost exactly as we predicted it in the finite element models. Next slide. As I said, this bogie frame was part of a completely new vehicle concept. I said a two-axle vehicle as an alternative to the existing Metro Madrid rolling stock. We foresee a great potential for a good business case here, but we had to work on two deficiencies that this type of vehicle has compared to conventional bogie based rolling stock. The ride comfort is less good because there is not primary and secondary suspension, but just one suspension step, and because it is not an ordinary bogie vehicle and there's a long distance between the two axles, the curving performance will be deteriorated, and both that deficiencies have to be worked on and can be dealt with by introducing active suspension in the vehicle. And that we did. If you go to the next slide, here I will just shortly mention the actuation for the curve steering that we worked on in the project. As you can see, two actuators are implemented, and as said, there were new actuators designed especially for this purpose, non-linear actuators, and tested in the laboratory to force the wheel sets into a radial position in the curve to minimize wear and risk for rolling contact fatigue on both wheels and rails. And if you go to the next slide, the final technical part of the project was the so-called wheel set of the future, where we developed a virtual demonstrator. In that work package, we didn't have the possibility to really manufacture the wheel set, but we did quite extensive studies. The benchmark was an inboard bearing wheel set sorry, from Lucchini, and the axle of that wheel set has a mass, the steel axle has a mass of about 200 kilograms, as you can see here. On the next slide, you can see we started with 3 different concepts and made a rough evaluation from the beginning. We had, for example, as you can see here in the center, the lowest cost concept, but in the end, since, as we said, weight reduction, reduction of energy consumption was very important in the project, we went for concept number 3, which promised the lowest mass, a 60% mass reduction. And with that concept, we then made all the detailed studies. If you go to the next slide. The concept is, as said, a hybrid metal composite axle, and there's, as you can see, a continuous composite tube, full length. The length is that of the full axle. Then you have to have thin-walled collars bounded on each side for fitting the bearings and the wheels. And then adhesive bonding is foreseen to be used to join the inner tube to the collars. And then there's also a secondary composite tube needed in the central portion of the axle to meet the bending stiffness requirements. And as indicated from the beginning, that axle is just 80 kilograms, according to our design studies, a 60% mass reduction. And when it comes to the whole wheel sets, there are, of course, also the bearings and the wheels, then we still have a 12% weight reduction compared to the benchmark axle, inboard bearing axle from Lucchini. The next slide, please. With that concept, we did a lot of design studies. We designed this, we calculated the statics and the dynamics of that axle. We made detailed proposals about a possible manufacturing process. We made an impact analysis, since an axle could be, for example, be hit by ballast stones or other things. So an impact analysis of the carbon material is very important. We looked into the joining with the collars. We looked on the effects on the running dynamics and the vibration of the vehicle, and we also made an LCC assessment with a universal cost model. And all this is described in detail. The next slide. The final part of the project that I want to present is the universal cost model 2.0, as we call it, because the first version was developed in an earlier shift to rail project called Roll to Rail, and our task was to make it much more user friendly and to add some features that were not really in the first part of the model. The basic idea is to make it easy to compare the life cycle costs of an innovation compared to an existing design. Historically, it has shown up that innovations that have been proposed in research projects didn't have it so easy to make it into the market. And some reasons of that is that the initial cost perhaps can increase a bit, and the initial cost is very much with the vehicle operator, but the benefits of a reduced operational costs, that means often a reduced maintenance cost, they are at least partly with the infrastructure owner, and therefore perhaps a vehicle operator still makes the decision to buy the vehicle with the lowest initial cost. And this tool should make it possible to show in a very easy way how the total life cycle costs of an innovation change the picture. On the next slide, you can see a little bit how the model should work. As I said, it's Excel based and it will be accessible for anyone. That Excel tool, you have to calculate some performance indicators, for example, the wear rate in millimeters per kilometer, the crack propagation rate, the track settlement rate, energy consumption, sound power. We also included hazards. And then there are instructions how these exactly should be calculated for a reference vehicle and the new design. And then you can compare the investment, operation, and end of life costs, which then end up to the total cost of ownership for that vehicle. To the next slide. We worked, for example, besides other features, we worked on the energy and noise tools in next year. They were included in the basic model, but what we, for example, added is country-dependent CO2 costs, because as you can see, the table is very small, but you can see that they differ a lot from country to country in Europe, for example. And when it comes to noise, also the noise we tried to translate into a cost. And there are different pass-by sound pressure levels defined for different areas like metropolitan, urban, rural areas. And that is also included now in the model. And then on the final slides, you will be able to see some examples of, or mainly one example on how that tool can be used. We picked again the innovative single axle vehicle and compared it to the standard bogie and the existing Metro Madrid trains. One train set, the conventional train has 3 train sets, and those are together 55 meters long, and the 2-axle vehicles needs 5 coaches to transport the same amount of passengers. So that was what was compared. And if you then go to the next slide, you can see that the universal cost model shows that the annuity, that means the yearly cost for the operator, for the ownership, is is reduced. We use the system performance demonstrator number 3 from shift to rail, the metro vehicle, of course, as comparison. And you can see per train set, the cost would be reduced from 15,600,000 euros to roughly 15 million. And if you go to the lower diagram on the right-hand side, you can see that for the new vehicle, the investment cost and also the end-of-life cost increase a little bit compared to the reference vehicle. But the operation cost is much lower, and that leads in the end to a lower complete total cost for the vehicle. And that's very important that we are able to show this with the UCM tool. Next slide. And the final 2 slides in my presentation are dedicated to the specific reduction in energy consumption we think we can achieve with the innovations we propose here. First, we calculated also for a run on Metro Madrid, on line 10, we took as the reference. First, if you run on straight track, the innovative vehicle would reduce the energy consumption compared to the existing one with about 5%. But then you also need to look at the additional energy consumption in curves. There's an additional curving resistance. And looking at all this, we calculated that all in all, we foresee a reduction in energy consumption of about 8% or a saving of 10 kilo euros a year per train set. I tried in my head to recalculate this to something a little bit more tangible and came up with an extremely rough number. But for the whole metro network in Madrid, that perhaps could translate into the energy consumption of 3,000 European households or so. But don't cite me on that number. That is a very rough calculation, of course, but just to give you any idea. And the final slide then shows the possible energy reduction or reduction in energy consumption for the wheel set of the future. First, the gray column is an outboard bearing wheel set on the metro SPD from shift to rail. And then in the middle, you have the same vehicle with an inboard bearing vehicle. And then you have our hybrid wheel set. And compared to the inboard bearing wheel set, we would reduce the energy consumption with roughly 4.8%, and compared to the outboard bearing wheel set with about 7%. And that was all I intended to present. So thank you very much for listening.
Thank you very much for your presentation. And just one question, as we were referring at the beginning, the collaboration that you had with the founding members of Shift2Rail. How would you, expecting additional questions later on, but how was this, so for you can maybe give a glimpse on how this collaboration was set and how everything was working with the other members within Shift2Rail, just to have a hint and before passing to the last presentation of the session.
Yeah. That cooperation was extremely important for us to get the input from the vehicle manufacturers and the operators and the infrastructure managers. For example, before we decided which application we use for additive manufacturing, we had meetings with the Pivot 2 consortium to ask for ideas, and together then we decided for the antenna bracket. And for example, also when it came to the development of the universal cost model, we started with a questionnaire with the Pivot 2 people to ask for what are your ideas of such a model and how should it look like. So as you say, Xavier, it was really very important for us to have the continuous interaction with the Pivot project.
Okay, thank you very much for the presentation. I invite you to stay also until the end. So once we get additional questions, you would be, of course, open to, or we'll be open to discuss. And right now we give now the floor to Alain Schreger from UIC, that is going to be presenting also, as previously our colleague from Sweden, the presentation on the main results and outcomes coming from Carbodin, another open call. And please, Alain, go ahead. The floor is yours. And later on, I just remind you that we will have this question and answers session, half an hour slot. But please send questions so we can address them to the speakers and to the team leaders participating today with us. Thank you. And Alain, the floor is yours.
Thank you very much. I will do my best to keep in line with the time schedule. So thank you for giving me the opportunity to present the conclusions of Carbodin. Carbodin is more based on parts, and of course inside of Carbodin we considered all the inputs coming from Pivot 2. So here you can see the different topics on which we worked inside of Carbodin. And well, let's go directly to the next here, so that we can see every topic. So this one, and as I'm UIC staff right now, I will insist on the how would I say, the RU side of things, the considerations of RU, even if we had a very strong and nice collaboration with all those people coming from different industries. So the first one is about modular tools for composite door leaves. Earlier, someone spoke about door leaves inside of Pivot 2, and so here we try to find industrial solutions for this. And of course, the RUs and the end users of this will be interested in the reduction of the energy consumption, the improvement of the acoustic comfort of the passengers. And as the automotive industry provides vehicles with constantly improving thermal and acoustic characteristics, our consumers, the end users of this, have increasingly high demands on this. So this will help to get quite quickly to have some door leaves. The methodology helps us to reduce the cost and also the time to the market for those components. Time to market availability of this methodology 2023. Let's go to the next one. An improved boarding device. I heard a few minutes ago someone from Pivot 2 speaking about this. So here we try to produce an example of what could be a boarding device for a train, for a commuter train, for people, for wheelchair users. So the UIC Passenger Forum has organized several working groups with disabled people associations, wheelchair users, and so on. And so one of the challenges is to accommodate those commuters in such a way that they can be independent as possible when they use the trains. Of course, we have to go on with the design of possible solutions, considering the different type of trains, the heights of the platform, which are quite different, the train stop times in stations, and for short and regular trains. And of course, we have also to consider the safety of the customers by connection to the TCMS of the trains. But for me, this is a very nice first step of what could be done, and for me, it's really interested to go further on considering the implementation on trains. Next, please. Yes, we also spoke inside of Pivot 2 about thermal and acoustic isolation, so I will not spend too much time on this. Here we have a solution to reduce both of them. And of course, reduction of the energy consumption, thermal comfort of the passengers is very, very important, especially in the areas that are near to the doors. Okay, available of this type of solutions 2025 to 2027. The next, please. So here we have a device concerning the thermal acoustic isolation of the what we are trying to do is to use Helmholtz resonators in the train structures to improve this. It's not really implemented, but it could. This methodology will enable a quick design of acoustic walls structures for sound attenuations. Of course, the users will be designers of rolling stock, specificators also of rolling stock, and all the other sectors where walls will be with sound attenuation can be applied. We know that RUs must have new walls installed inside of trains to have the interiors adapted to the passengers' needs. That's what was said inside of Pivot 2. The interiors have to be modified several times during the time life of a train, every 10 to 12 years, if I understand well. And so these are quite nice solutions that do not increase heavily the mass of the train, and who give us a very nice level of comfort for our customers. Availability 2023 to 2024. Next, please. Well, integrated low voltage in tunnels. Currently, we have, how would I say, the information given to the passengers on board of the train via screens, personal ITs, tools become very essential to our passengers. They want to know a lot of things about actual running times, train station connections with other trains, with other means of transportation, seat occupancy, infotainment, of course, because we also have a lot of people using these possibilities. So this methodology, this way of distributing energy inside of the train is important. Currently, we don't know exactly when it will be accessible on the market, but for us, it's really nice to have such methodologies, such techniques to go on with all the other things that we are going to develop inside, with all the services we are going to develop inside of the trains. Next, please. Well, I was in charge in the past years of projects for refurbishments of French high-speed trains. And so I know that it's quite complicated to come to a solution when everyone tries to understand how we are going to evaluate with the interiors of a train. And so this methodology of virtual immersive interior design should be something really nice and could reduce the time that is needed for making the right decisions when a new train has to be bought or when the retrofitting of an existing train has to be made. And so my former colleagues working with me or my former marketing colleagues will probably be completely agree on this with me. Next, please. Here we're going more deeply into the detail of industrial production of parts made. So we had a very nice, very interesting work on infusion process simulations. Currently, the production of those parts is quite, how would I say, that it's done with people which have a lot of experience and needs a lot of testing and things like that. If we go to this new way of simulating what's going on in the molds, we shall also be able to select the best resin inlet, outlet positions, and so on. It will be easier for everyone to come quickly to the right solution for the trains. New trains being built or retrofitting or maintenance of existing trains. So this will help to reduce the production prices, the delays by avoiding parts of the test that are currently made when beginning of the production. Next, please. I will not insist on this. Our colleagues from Pivot 2 explained a lot about the structures around the doors. And so here you can find some examples, some solutions that can be quickly adapted to every situation. And so, well, I should say nothing to be added to this. We are currently working for considering the outputs for Pivot 2, and so those are solutions to be applied, considering the solutions that are given to us by Pivot 2. Next, the next concerns one more time modular molds. This is one more way to reduce the costs and the delays, optimizing the production process of parts to be used. And so for us, having that kind of methodology will be easier to specify the parts to be used, and also to produce those parts and to have a quick access to those parts, for instance, for the maintenance purposes. So this is ready to be used. The one in just before was also ready to be used. Okay, next, please. The next one is about the structural health monitoring. Someone spoke about the maintenance of the car bodies, and here we have the possibility to monitor the behavior of these car bodies and identify clearly when something has to be done on the car body, because those maintenance activities are usually very time consuming, and we have to understand quickly when some heavy maintenance of these parts are needed. So having those devices, having the possibility to monitor the car body will be for us at most important. Okay. And then let's go to the next one. Well, here we are also working on the optimization of the production process, the reduction of the delays and the costs. And this will be available in 2024, 2025. And as a maintenance expert dealing with those aspects, we had in the past, and we still have issues on the inserts of the composite parts of the trains. And so having those methodologies for dimensioning those inserts, we will be happy to avoid that kind of problems in the future. Available on 2024 to 2025. Next, please. Well, this one is really important because we spoke a lot about the possibility to have modular interiors for the trains. So every 10 years, we will have to change those interiors to adapt to what our customers want us to have. And here you have an example, a very nice example of what can be done. And so you can see here that we have the possibility to modify the interiors without having heavy work on the interior. So we will save a lot of time changing the interiors, and it will be possible for us to adapt them very quickly by changing the floor, changing everything inside, the position of the seats, for instance, but everything else inside. So this should give our users the possibility to adapt the interiors of the trains quite quickly to new needs of our customers. Okay, then the next and the last one. These are all the members who are participating to our car body project, and there are people coming from the industry, some representatives of the RUs, and of course people coming from the universities and so on. And really, thank you very much, because this was a really interesting project and giving a first set of solutions, going more in detail to the solutions that were proposed by Pivot 2. So thank you very much for your attention, and okay.
Thank you very much, Alain, for the presentation and for the insights on the activities that Carboline has been working upon, from specific solutions providing better accessibility to the market and to the railway sector in particular. Also in interiors, as also mentioned at the beginning, some of these innovations were shown at InnoTrans with these technologies developed, and of course this important aspect also dealing with maintenance and how these car body structures can be better monitored and to have activities on those maintenance tasks to be performed in due time. Thanks you again for the presentation and for your insights. And as mentioned at the beginning, we are now having a slot for questions and answers. So any of the colleagues, any of the people attending the session, this first session of the Innovation Days today, please don't hesitate to either send your questions through the chat, or please, you can also raise your hands, and we might be able at this stage to, within a few seconds delay, to give you the floor and give you the floor to ask it. But you have to make yourself visible that way, either raising your hand or providing the question through the chat. In the meanwhile, I would also, as also introduced at the beginning, give also the floor to Javier, maybe for some closing remarks or closing statements on this session today. If you would like to add something to what has been presented today, please go ahead while we expect some questions from the audience. Go ahead, Javier.
Yes, thank you. First of all, don't be shy and ask some questions. I think there are very interesting topics presented today, starting from the lightweight car body shells through the monitoring system for the bogies, the lightweight bogies, the doors, the interiors, the modularity for the interiors. So I think in general, the IP2 activities along the last years have been fulfilling the expectations. Now we see today the results of the research program. Also, as you mentioned, Javier, also during InnoTrans, we were able to see and touch some of the innovations. Many of them, again, targeting the energy consumption reduction, either directly or indirectly. So in general terms, we can conclude that IP1 now is finishing the activities. We are showing today some of the results. Nevertheless, there are other TDs such as TD11 traction and TD12 TCMS that will finish also in the next months. By the way, there is, for your information, the final conference of PINTA 3 is taking place next week. So in Brussels,
registrations are still open, so please don't hesitate to also.
Yeah. As you know, in PINTA 3, we have also a very interesting results presenting not only the traction converter based on silicon carbide, but also we have the independent motor wheel solution from Talgo. There are several demonstrators from CAF, from Alstom. We have the EM brake also unveiled in InnoTrans, so the electromechanic brake. Very interesting topics. I think also the HVAC is there in PINTA 3.
Yep.
So, I mean, there are also a lot of topics related to energy consumption, to at the end, fostering, promoting railways as the backbone of the mobility system in Europe. So you are kindly invited to attend this final conference, and obviously the next final conferences of our projects, Pivot 2, Connecta 3, that will take place in the next months.
Yeah, all of them are also published in our website, and we also make promotion of them. So please don't hesitate, as Javier was mentioning, to join us on those final events, so you can see the conclusions and the activities that these projects have been working upon. Well, Javier, we don't see any questions coming in.
No. So I wanted to say that last but not least, it must be highlighted that it was also mentioned this morning by Carlo and Giorgio that many of these innovations, which are reaching certain TRL, certain maturity, we will further develop and demonstrate it in Europe's rail, in the different flagship areas, mainly flagship area 4. Some of them may be also coming MS and communications in flagship area 2. So this is not the end of the story, it's just the first chapter of the story.
Indeed, flagship area also, flagship area 6, there's also some links identified in there.
Flagship area 3 for the monitoring systems, for the digital twins of bogies and this type of technology. So I think many of the flagship areas will continue with IP1 activities and results.
Topics identified, yeah, indeed.
Yeah.
Well, thank you very much, Javier. Thank you, everyone, for joining us today. We don't have questions, so I will just mention that from 12:30 to 1:30, there was a dedicated slot for the lunch break, so you will have more time now to have this break, so you can enjoy it even for a longer time. And then just remind you that the link for the CCA session is in the agenda, and it's a different one to this one. So please, you will have to go in the agenda and click in there. This will be the way you will have the access to it. And then please, for the following sessions, also have the agenda by yourself, because in there you will have the links that will allow you to join the different slots. Okay, so in that sense, I just would like to thank you again for your participation, for being here with us today, and of course invite you to continue with us this afternoon and the next 2 days with the colleagues that will be presenting all the activities within the Shift to Rail program. Thank you very much again, Javier. Thank you also for the collaboration, all the TD leaders involved, all the project coordinators that have been presenting today. Thanks again, and of course we keep in touch, and see you soon. Thank you very much.
Thank you. Goodbye.
Bye-bye.